Chapter 9C number 6 is a rotation problem on a graph. And it says we're going to rotate from A to A prime by 75 degrees. And it's centered, now it's not centered at 0, 0, which is going to make this problem a little trickier. It's centered at 1, 2 instead. So one of the things we have to do first is find the radius. So we're going to solve for the radius right here. And it turns out, remember, this is also the radius. Really, this is all part of one gigantic circle that would be going around like this. I'll get that out of the way just so it's not there the whole time. So this is a radius, and this is a radius. And I can solve for it by making a slope triangle right here. And so when I go up and down, the y values change. I'm changing from 2 to 3, so that's a y value of 1. And then when I go across, the x's change from 1 to 7, so that's 6. And so I can do 1 squared plus 6 squared equals r squared. And if I work that out, I'm going to get root 37 is r. So root 37 here, root 37 here. Okay, so that's first part. Okay, next part. I need to figure out, well, let's see, why is the 75 useful? Well, that's the arc that it carves out. And this part right here is the central angle. So this is also 75 degrees. The goal is to get where A prime is. And since I'm starting at 1, 2, if I could figure out how far down and how far over to go, I could just count from 1, 2. So the only way to do that, I have the root 37 here, but if I knew what this angle was, which I'll call beta, then I could use trig to get like this A and this B so that I could count down and over from 1, 2. The only way to get beta, though, is to get this angle right here, which I'm marking theta right there. So if I could solve for theta, then I could do theta plus 75 plus beta equals 180 degrees. So now let's solve for theta. So I'm going to use the 6 and the 1, which are the opposite and the adjacent sides. So that's going to be tan theta equals 6 over 1. So theta is going to be the inverse tan of 6 over 1, which comes out to be 80.5377 degrees, let's say. And so then that means beta is going to be 180 degrees minus 80.5377 plus that 75 central angle. And so that comes out to be 24.4623 degrees. So now we've got our beta. And so now we got to solve for our A and our B. So I'm going to switch to green so it matches the triangle we're using here. And let's solve for A first. So that's the opposite side, and we have the hypotenuse. So that uses sine. So I'm going to do sine of beta, which is 24.4623, equals the opposite side over the hypotenuse, root 37. When I multiply over the root 37, I get A, which comes out to be, let's see here, root 37 times sine 24.4623, 2.519. So that's A. Okay, B is the adjacent side, so if we use adjacent hypotenuse, that's cosine. So cosine of 24.4623 equals B over root 37. If we multiply over the root 37, we get B, which comes out to be 5.537. So now we've got this. This side here is 5.537, this side here is 2.519, and the point that we're starting from is 1, 2. So let me just draw that important part right here. Let's say this is the point 1, 2. I'm going to drop down 5.537, and then I'm going to go across 2.519. And the question is, where do we end up at A prime here? Well, when I go up and down this way, the y values change. So I started at 2, and I'm going downwards. So the y value is going to end up being 2 minus the amount that I dropped, 5.537. And the x values change when I go to the right. They increase. So I started at 1, and I increased by 2.519. So my final answers here, A prime is going to be 3.519 and negative 3.537.